With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
In a container of negligible heat capacity, 200 gram ice at 0 degrees Celsius and 100 gram steam at 100 degrees Celsius are added to 200 gram of water that has temperature 55 degrees Celsius. Assume no heat is lost to the surroundings and the pressure in the container is constant of 1 atm. At the final temperature, mass of the total water present in the system is. Okay. So let's try to find the final temperature of the system first. For doing that, what I'm going to do is I'm going to add up all the energies that are being absorbed or released in the form of heat in this system, because there is no heat that is being exchanged from the surroundings that are outside the system. So how do I do that? Let's start. We have 200 grams of ice, right? So 200 grams of ice will absorb some heat. So minus 200 grams. Now, first of all, the heat, it will absorb heat to convert into water. So minus 200 into the latent heat of fusion for ice is 80 calorie per gram. So minus 200 into 80 plus. Now the steam will release some heat to convert into water. So 100 grams of steam, 100 grams of steam multiplied by the latent heat of vaporization, that is 540 calorie per gram. Now let's say that the temperature, the final temperature of the mixture is capital T. So the water that is at 55 degrees Celsius will try to reach this temperature. So let's say 55 minus T multiplied by, now the mass of the water, that is 200 grams, into the specific heat, which is 1, plus the water that we have obtained by melting of ice. So 200 into 1 into 0 minus capital T, plus the water obtained from the steam. So that would be 100 grams into 100 minus capital T into 1. This should be equal to 0. Let's solve for capital T. So minus 16,000 plus 54,000 plus 200 into 55 minus 200 capital T plus 200 into 0 minus 200 times capital T plus 100 times 100 minus 100 times capital T is equal to 0. So let's bring all the terms with capital T to the left hand side. So we have minus 200 T minus 200 T minus 100 T is equal to 16,000 minus 54,000 minus 200 into 55 minus 10,000, which gives us, on the left hand side, this will become minus 500 capital T is equal to 16,000 minus 54,000 minus 55 into 2, that is 11000 minus 10,000. So this gives us 54 minus 16 plus 11 plus 10 is 59,500, which means capital T is 118 degree Celsius. Now, 118 degrees Celsius means that the the temperature that is being obtained is higher than the boiling point, which means that our assumption that all of the three things will convert into liquid of some temperature capital T is somewhat wrong. This means that up to a certain point out of the mixture, some mass capital M will turn into water at 100 degrees Celsius, but the, some other mass, let's say small m, will turn into steam. Or since we had started with the steam as an initial product, some of the steam will remain steam and will not convert into water. So now capital M plus small m must be equal to the total sum of the products, that is 200 gram of ice, 100 gram of steam plus 200 gram of water. So 500 grams, which means small m can be written as 500 minus capital M. And we have to find the mass of the total water present in the system. So this capital M is the mass of water left. Okay. So now what I'm going to do is I'm once again going to write all the heat energy that is being transferred inside the system. But this time I will use the value of temperature T from here, and I will add one more term to account for the fact that some mass of the mixture is converted into steam. So let's once again write it. Actually, we can copy it from the earlier. So minus 200 into 80 minus 200 into 80 plus 100 into 540, 100 into 540 plus 55 minus capital T. 55 minus, for capital T I will use 100 degrees Celsius because that is the maximum temperature water will achieve before converting into steam. So 55 minus 100 into 200 into 200 into 1 plus 200 into 0 minus capital T, 200 into 1 into 0 minus once again 100 degrees plus 100 into 100 minus capital T. So 100 into 100 minus capital T, which is 100. So this term will turn out to be 0 eventually. And now I will add one more term. This term is going to signify the mass that is converted into steam. So the latent heat of vaporization 540. So small m into 540 is equal to 0. So let's solve this. Let's simplify this. So minus 200 into 80 is minus 16,000 plus 54,000 plus 55 minus 100 is minus of 45 into 200 plus 200 into minus of 100 plus this term will become 0 minus small m can be replaced by 500 minus capital M, where capital M is the final mass of the water in the system. So 500 minus capital M into 540 is equal to 0. Let's further simplify this. So minus 16,000 plus 54,000 minus 2 times 45 is 90, so 9,000 minus 20,000 minus 540 into 500 is 270,000. So 270,000 is equal to, let's bring the m term to the right hand side. So minus minus plus, turning it to right hand side will give me again a minus 540 capital M. So let's add all these terms up. 540 M should be equal to 15. So adding these terms, it turns out to be 261,000, which means capital M is equal to 261,000 divided by 540, which is 483.33 grams. So our answer should be option number B, 483.3 grams.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.